Hello, Middle 3, and welcome back to the second lesson in Unit 1. The second lesson in Unit 1 will be also about chemistry. It's about the speed of chemical reaction. Okay, this means that some chemical reaction is faster than another chemical reaction. This means also that there is something that controls the speed of chemical reaction. Okay, in this lesson we will discuss what is the factors that affect the speed of chemical reaction, of course, and we will know how they affect it. Introduction, we have a small introduction. First of all, we know that chemical reaction changes a substance into another substance, of course, as we know. Number two, the chemical reaction differ in the time that they take to occur, as the following example. Some reaction occur in very short time, like fireworks. If you use fireworks, you can say that it's very short time chemical reaction. Some reaction occur in shorter time, as the reaction between oil and caustic soda, NaOH. Okay, and some reaction needs several months, like iron rusting, and some examples needs millions of years to occur, as the reaction of petroleum oil inside the earth. The following reaction, the meaning of the speed of chemical reaction, like if we have N2O5. Okay, N2O5 means nitrogen pentoxide. The word pent means 5. Okay, nitrogen, of course, N. So nitrogen pentoxide, that means nitrogen which have 5 oxide, nitrogen pentoxide. The nitrogen pentoxide decomposes to give nitrogen oxide and oxygen. Nitrogen oxide and oxygen. This is that. Nitrogen, of course, nitrogen oxide here is nitrogen dioxide because it has 2 oxygen. Okay. We have a graph right here. This graph represents in this line the concentration mole per liter. Okay, and the time right here. Okay, this is again great. Over time, we see that the concentration changed over time, like the concentration of N2O5. At the beginning, it was the greatest one, so it began to decrease like this, and the concentration of O2 and NO2, over time it begins to increase like this. It increased over time. Okay, of course we have that NO2 is have higher concentration than O2 because of course in the reaction we have 4 NO2 and just only 1 O2. Okay, so NO2 is 4 times bigger than O2. Okay, let's have here the conclusion of this one. Okay, you can study this by your own. It's very easy, and we study that. The speed of chemical reaction. What's the meaning of speed chemical reaction? Okay, it is a change in the concentration, as we said in the graph before. It is a change in the concentration of reactant and resultant in a unit time. Measuring the speed of chemical reaction, if we have NaOH, which is sodium hydroxide, and CuSO4, which is copper sulfate, we know it's blue from the previous example we have in lesson 1. Okay, what will they produce? They will produce Na2SO4, which is sodium sulfate. Okay, of course, the O4 here is a small one. Okay, this sodium sulfate is colorless. Okay, and CuOH by 2 is a copper hydroxide, which is blue PET, blue precipitate. Okay, again, the reaction again, we have NaOH, sodium hydroxide, we will add it to copper sulfate, CuSO4, which is blue in color, and the result will be 2 results. The first result we have is called sodium sulfate, which is Na2SO4. This is colorless, has no color at all. and the second one is CuOH by 2, which is copper hydroxide, which is blue in color. Okay, this is the reaction we have. Okay, what is PPT? PPT means precipitate. Precipitate means that it's just not liquid, it's a solid material like this. Here the color will be liquid, and the color here is just a solid material, will be precipitated like powder. Okay, this is the meaning of the reaction. Many factors affecting the speed of a chemical reaction. As we said, the chemical reaction change over time. Some chemical reaction has more speed, some chemical reaction has low speed. But why some chemical reaction has very fast speed and some of them is very low? This is due to some factors. We will discuss them now. So we have many factors affecting the speed of chemical reaction. We'll see. Factor number 1, the nature of reactants. Factor number 2, the concentration of reactants. Factor number 3, the temperature of reactant. Factor number 4, the catalyst. Catalyst, we heard about it before, but of course we forgot about that. So we will discuss this later. So first thing we have here is the nature of reactant. Nature of reactant, this depends on the type of bond. We of course have two types of bond, two main types of bond, not all bonds. Hydrogen bond, not hydrogen here. Of course, hydrogen bond is a type of bond, but the main two types of bond is covalent bond and ionic bond. So the two types of bonds, this depends on them, ionic or covalent. The nature of reactant, again, the kind of bonding, either covalent or ionic, and the surface area. Of course, if the surface area increases, so the speed of the reaction will increase. First of all, the kind of bonding in reactant. Covalent bond, as we said, covalent bond or ionic bond. What's the difference between them? Between ionic and covalent bonds. First, covalent. Covalent compounds such as organic compound. What is the meaning of organic compound? Organic compound, any compound that is resulted from a living organism, like your hair, your nail, the paper you use that is made up of wood. Anything resulted from organic organisms or living organisms. Okay, so covalent compounds such as organic compound react slowly because they take place between molecules, while ionic compounds react very fast because they take place between ions. Example, if we have NaCl, it's ionic, and AgNO3, of course, is ionic, so the result will be AgCl and NaNO3. So this is very fast because they are ions. They take place between molecules. Not molecule, between atoms or ions. Okay, this is how we can figure it. They can dissolve in water into atoms or ions, and it's easy for ions to attach again with each other. Okay, the surface area. Of course, the surface area is very important. If we have right here, we have here two tubes. Both of them has hydrochloric acid, but in here we have a tube or a rod of iron, and here we have the same mass of iron, but it's not a rod of iron, it's iron fillings. So what is the difference between them? Of course, the reaction will happen here faster because here we have iron fillings which has more surface area. It's like this, Fe plus HCl, of course diluted HCl, because concentrated HCl is very dangerous. This will produce FeCl2 plus H2. Okay, that's great. Okay, the effect of concentration of a reactant on the speed of chemical reaction. The effect of concentration concentration, sorry, okay, the effect of concentration of reactant on the speed of reaction. Of course, if the concentration increase, the speed of the reaction will increase, of course. Consider the burning of aluminum coil in the following cases. In A, we have this A and B. In A case, yes, let's make it smaller to see them. Okay, in A, aluminum burn with O2 found in the air. O2 is only 21% in the atmosphere. In B, yes, in B, burn in container which contain O2, pure O2, 100% of O2. Observations: the aluminum react faster in case B. The conclusion we have that the concentration of the reactant increase, more collision between molecules take place, and therefore the rate or speed of reaction increase. If we have Mg and we have HeCl, the product will be MgCl2 plus H2 will go up. Okay. The effect of temperature on the speed, the temperature. Okay, by increasing the temperature, increases the rate of chemical reaction. Of course, if we increase the temperature, the rate of the chemical reaction, of course, will increase. And if we decrease the temperature, of course, the rate of chemical reaction will decrease and even may completely stop if we decrease the temperature of the reaction. Like in bacteria spoil food through chemical reaction. That's why food is cooled or frozen to slow the rate of reaction or stopping it. Okay, like a cook increase the temperature to speed up the chemical reaction that help in cooking food, like fried potato. Okay, activity number 3, to prove that the effect of heat on the rate of the reaction, we have two beakers, beaker A and beaker B. In beaker A, we have hot water and effervescence tablets. And in beaker B, we have cold water and effervescent tablets. Okay, the great number of bubbles in beaker A, of course, beaker A, indicates that the rate of reaction in beaker A, the rate of reaction is higher than in beaker B. This is obvious. Okay, number 4 and the last one, the catalyst. What is the meaning of catalyst? The catalyst we have is a substance which speeds up the chemical reaction without sharing in it. Without sharing in it. This is very important to know that without sharing in it. Again, without sharing in it. Again, without sharing in it. Okay, let's go back because it's hidden. Okay, we have two types of catalysts, in fact, the positive catalyst and the negative catalyst. The difference between them, that the positive one speed up the reaction and the negative one slow down the reaction. It's very obvious. Okay, the properties of catalyst. We have some properties of catalyst. We should be aware of them. Number 1, they change the speed of the reaction but don't affect either its beginning or stopping. Again, they change the speed of the reaction but don't affect either its beginning or stopping. Don't affect the beginning or stopping, just changing the speed by speed up or slow down. Number 2, the mass of the catalyst isn't changed by the reaction, so the mass isn't not changed. Number 3, the catalyst isn't changed chemically. Okay, the catalyst is not changed, not affected at all. Number 4, the catalyst combine with the reactant and separate from the product at the end of the reaction. The catalyst combine with the reactant and separates from the product. Okay, so it go away at the end of the reaction. Number 5, the catalyst is used in a small amount. Just a small amount is perfect to complete the reaction. Number 6, the catalyst decrease the energy The catalyst decrease the energy needed for the reaction. Of course, we have an activity here, activity number 4. Like if we have H2O2, which is called hydrogen peroxide. Hydrogen peroxide, if we remember, we have it in Junior 6. Of course, you don't remember, but you remember we do this experiment more and more in the lab. Okay, hydrogen peroxide, which has more oxygen, so we add manganese dioxide to it, which is catalyst, so this will produce water and oxygen. Okay, so the catalyst began to dissociate or take the oxygen out from the hydrogen peroxide. Okay, so the catalyst here is manganese dioxide. So manganese dioxide is a catalyst which speed up the reaction. It doesn't change at all, but it's just speed the chemical reaction. Okay, activity number 5. To show the effect of enzymes on the rate of reaction. The enzyme is biologically molecules. It's molecules. The enzymes are molecules which act as a catalyst. And example of enzyme is oxidase enzyme found in sweet potato. Okay, in our body we have some types of catalysts. We don't say that they are catalysts because they are inside our body. So we say that they are not catalysts, they are enzymes. So enzymes are exactly a catalyst inside our human body. Okay, oxidase or oxidase enzyme in sweet potato speed up the breaking of hydrogen peroxide. Of course, it acts like manganese dioxide. Okay, so the definition of enzyme, we have heard that enzymes, they are chemical substance produced by the body of a living organism, act as a catalyst. Of course, it's a positive catalyst. We have not an enzyme that slow down the chemical reaction, so they only increase the speed of biological reactions. Okay, this is the definition of enzyme. Okay, we have something called the catalyst converter. This catalyst converter is found in the modern or most of the modern cars. It is a metallic can, exists in the most modern car to treat the harmful gases emitted from engine. The structure of the catalytic converter or the catalytic converter, the structure of it is composed of a ceramic cell similar to B cell, just similar to B cell like this. 1, 2, 3, 4, like this. Okay, covered with a thin layer of catalytic metal like platinum or palladium. These are of course expensive very, very expensive metals. The importance of it helps in the treatment of harmful gases emitted from car engine. The idea of operation, ceramic cells like the B cell, which increase the surface area, and of course we know that when we increase the surface area, the speed of the chemical reaction of course will increase. Number 2, the catalyst increase the speed of the reaction. Yes, the catalyst increase the speed of reaction of treatment of the harmful gases emitted from the engine. Okay, and now we have ended our lesson. This is lesson 2 of Unit 1. See you later and goodbye.